Welcome to JCE Connect. In the previous class, we were discussing about some of the traps uh, which are required in the distribution network. So we have discussed S type of traps. We have discussed uh, Q type of traps. We have discussed the P type of traps and where exactly the location of those traps. Then we'll move on to the very important component of this sewer systems, that is a sampling. Always the sampling, why it is important means if you want to design, any water treatment plant or sorry wastewater treatment plant, first it will start with the the sampling of the wastewater and the characteristics of the wastewater. So the objective of the sampling is to collect uh, the representative sample, that is what there in the sewage. The representative sample by means a sample in which the relative proportions or the concentration of all the pertinent components will be the same as the material is being sampled. So means it means that, for example, you have sewer is there, in that you have sewage is there. Assume that the sewage consists of many of the things. We'll discuss that, which are the constituents or the properties of the sewage. This sewage is consists of physical characteristics, chemical characteristics, biological characteristics. This physical, chemical, and biological characteristics are uh, are the main components. And if we observe the characteristics of this, it should represent one um, standard characteristics. Means uh, so always whenever you are doing some of the sewage samples, already determined some of the standard characteristics will be there. For example, pH is one parameter. pH of the all sewage, always it will be in the range of 4 to 6. Even if you do the analysis for pH in the sewer, it should represent the standard representative samples. Um, means that much accurate your sampling should be. If you do any sampling, it should represent some of the standard characteristics of the sampling. That we can call it as a representative sample. So moreover, some of the samples will be handled in such a way that no significant changes in the composition occur before the tests are made. This is very important statement. Means whatever the characteristics what we are talking, for example, is pH is 1. For example, temperature of the sewage is also one very important characteristics of the sewage. So assume that you are whenever you are doing the sampling, assume that at the site or at the field, assume that the pH is or the temperature is 25 degrees centigrade of the sewage. Suppose if you bring this to the lab, there also it should have means it should represent the uh, field characteristics. Normally what will happen is that suppose if it is changing during your transportation, if the characteristics is changing, then you won't get exact, because temperature is interlinked with many of them characteristics. Automatically they are going to change. Then what we are talking about, the representative of the sample, or the objective of the sampling is going to be not correct or it is not the proper objectives. So then, before the test, the characteristic should remain same. Then you have to preserve the sample so that during the transportation, if the temperature is 35 degrees centigrade, you have to maintain it well. Then the sample volume is also a very important component. Even it should not be decreased. So how much quantity is required for each of the test has to be calculated before the sampling, and proper volume should be collected in a proper vessels. So then, because of the increase in the placed on verifying the accuracy and representatives of the data, greater emphasis is placed on proper sample collection, tracking, and preservation of the techniques. So whenever you start with the sampling technique, always you start with how exactly the sample can be collected, how it can be tracked, how it should be preserved for the long time. What will happen is that today you will bring the severe sample. Suppose if you are doing the testing after 2 days, then the characteristics of the field should represent often after 2 days. So that is why always we have to preserve the sample. Normally we'll preserve below 4 degree centigrade. If you preserve it in coolers, normally the characteristics will not change. If I say the preserving in the greater than or lesser than 4 degrees centigrade, the whatever the activities, biological activities, or the viruses or that has bacteria which are present in the um, sewage, they are not active in this temperature. They are not active. If they are not active, normally the characteristics will not change. So after laboratory personal help in planning the sampling program in consultation with the user of the test results, always we have to go ahead with the consultation of the proper protocols or the proper laboratories. So whenever we are doing the samples, some systematic protocols has to be maintained in consultation with the technical persons. So such consultation is essential to ensure the selecting samples and analytical methods that provide a sound as well as a valid basis for answering the questions that are prompted the sampling, and that will meet the regulatory as well as the project specific requirements. Whenever you are doing the samplings, always first you finalize the analytical methods. If I say it is an analytical method, uh, uh, it is very important because each analytical methods having its own preservation techniques. For example, for the pH, if you want to determine it, uh, something like you have to preserve it for below 8 degrees centigrade, and you have to store it for some of the using alcoholic um, preservatives are available. In that, you have to preserve it. So, and the regulatory bodies like um, KSPCB, Central Pollution Control Board, they have made some of the standards for each of these testing facilities. So then always we have to see all those regulatory authorities, and we have to go ahead with the um, sampling. So then the general information always we have to collect um, whenever we are doing the sampling. So first one is always go ahead with the sampling identification number. How you have to identify, like something you give your number so that you can identify it or you can differentiate it with one another. So then always location, the sample collector, date hour, and the sample type. Some of the specific information uh, that has to be maintained during the sampling, that is water temperature, weather, stream flow means what is the velocity, what is the flow, then water level, what will be the water level, or any other information related to the sampling has to be collected. So then the sampling techniques uh, are there. There are three types of sampling techniques are there. That is the grab sample, uh, this grab sample, then composite sample, and the integrated sample. Then what is this grab sample is? Grab samples are single collected at a specific spot at a site over a short period of time. Means the person will go to at some spot and he will collect at, for example, at 3 o'clock. Again, he will go to one more spot, spot 1, spot 2, he will go to 4 o'clock. Then he is grabbing the samples at different locations at different times. This we can call it as a grab sample. So they represent a snapshot in both the space and time of sampling area. So discrete grab samples are taken. When I say it is a discrete, um, the sample is collected at different locations at different times. So then it has to be selected at the location, depth, and time. Depth integrated grab samples are collected over a predetermined part of the entire depth of the water column at a selected location and a time in a given body of water. So at present, you can assume that the grab samples are collected at different locations at different timings. So the composite samples we will discuss in the next class.